Good day, everyone. I am Maribon Rumbawa, and today I am discussing to you about Poisson's equation. So this is the general formula of Poisson's equation. That the relationship between electric field and electric potential. Where E is the gradient of electric potential in opposite direction, Gauss's law in point form, which is the divergence of electric flux density, which is equal to the total volume charge density. So, we let electric field is equal to the negative del phi as equation 1. And divergence of electric flux density, which is equal to the total volume charge density as equation 2. So here is the solution. First, we need to evaluate divergence of electric flux density, which is equal to the total volume charge density. Then, we factor out epsilon So, we have epsilon of del electric field equals to the volume charge density. So we get epsilon of del charge electric field over epsilon equals to volume charge density over epsilon. And get del electric field is equal to the volume charge density over epsilon. And then to get and then plug in the equation 1 to get the then we factor out del to get the Poisson's equation. So here is the Poisson's equation. Negative of del squared of phi is equal to the rho v over epsilon. So this is the general formula of Poisson's equation. General equation of Poisson's equation of Cartesian's x, y, z. We can represent del squared as partial partial of squared over partial of x plus partial of 2 squared over partial of y plus partial of squared over partial of z thus for each coordinate system we get. So phi is equal to partial of 2 phi over partial of x squared plus partial of squared phi over partial of y squared plus partial of squared phi over partial of z squared for rectangular coordinates. And phi equals to 1 over r squared partial of 2 over partial of r r squared sorry. Open parenthesis r squared partial of phi over partial of r plus plus 1 over r squared sine theta partial over partial of theta. Sine of theta partial of phi over partial of phi for spherical coordinates. So phi equals to 1 over r partial of partial over partial of R. Open R partial of P over partial of P over partial of R. Plus 1 over R squared partial of squared phi over partial over partial of theta squared plus partial of squared phi over partial of z squared for cylindrical coordinates. So, Poisson's equation can be used or evaluate such system if it has volume charge density. And if it is 0, then we restore to Laplace's equation, which is del square of V equals to 0. I hope you learned something today. Thank you so much, everyone.